Hey guys, so this is take two for me. For some reason, the Chromebook was like, we're gonna stop recording stuff and be real weird. So, first round for you, second round for me. Um, let's see. Sorry. So, most of you have probably already started on stuff before watching the lecture, which is perfectly fine. No problem with me. This is just me kind of going through the PowerPoint with you. Today, on Tuesday, you can see I've added into the weekly rundown. What we're doing today. Not sure if we're going to be in person tomorrow. If not, same deal. Come to the Google Classroom. I will have Wednesday stuff uploaded in there. If we are virtual again tomorrow, I'll probably post a little bit less stuff just to give you some time to get caught up because I'm not sure what you're doing in your other classes. But like I was saying, today is more of the review section. We are going to be talking about metric units. I've provided you a little cheat sheet since this is just review. You can go through and look at that. If you're in person, I will get you a hard copy of this to stick in your binder. Then we have some measurement questions. If you read the directions, it says the questions are in the second set of slides. So I will be going through whenever you watch this, you'll see me go through those questions and I will read them. I won't answer them quite yet. But I may give you some pointers like think of this or think of this. And then after the questions, I want you to watch the short little video I have of scientific notation and then do that little short activity. It has, I think, 16 questions. It's nothing too crazy. But scientific notation is just an easier way to represent or communicate really big numbers. So you'll kind of hear about that in that video that I've posted. Again, this is all just review, so nothing too like, oh, I have to know every single thing. But it is very important that you do know how to use the metric system because in science we use the metric system and not the standard or English system that you're used to. So as you see, that's all right here under the weekly rundown in week 2. We are going to go ahead and start with the first set of slides. I was in the middle of this one whenever the first recording shut off. But let's see. So, metric units. They're different than what we are used to using because we are used to using feet, yards, inches, gallons, quarts, fluid ounces, things like that. So this is going to kind of show some comparisons. Miles are longer than a kilometer. So miles is our standard version or English version, and then the kilometer is the metric. Our yard, which is 3 feet, and 100 of these make up a football field. A yard is smaller than a meter. In my classroom, I have meter sticks, which you can see here the difference in length. Oh, sorry. And then an inch, which is what we're used to seeing on a normal ruler, is much larger than 1 centimeter. So these two versions or these two systems, they're not one-to-one. You can't just say 1 mile is 1 kilometer. They're different measurements. So that's important to know whenever you're going between the two. So the basic unit of length for the metric system is going to be the meter, and we represent that by a small m. Sorry, that's my hot chocolate. Okay, so also have the standard distance traveled by light in a vacuum. It has that on there. And then this is the main part of this slide right here that you need to know. 1 kilometer or 1 km equals 1,000 meters. 1 meter equals 100 centimeters. And 1 meter also equals 1,000 millimeters. And if you go back to this page, you can see here. So this is 1 centimeter right here. And if you count these little lines are the millimeters. So there's 10 millimeters per centimeter. And there's 100 centimeters per meter, and then there's 1,000 meters per kilometer. So the metric system is very easy in this sense because it's in base 10. So, unlike with the foot, you have eighths and quarters and halves, and then so on and so on. So, this may be a little easier math wise. So, down at these questions here, 1 meter. So, which one's larger, 1 meter or 105 centimeters? If we look up here, we know that 1 meter is 100 centimeters. So we could replace this with 100 centimeters or 105 centimeters. Clearly, this one is larger. And then on B, where it says 4 kilometers or 4,400 meters. Again, we'll go up here. We know that 1 kilometer is 1,000 meters. So 4,000 meters or 4,400. Clearly, it's going to be the 4,400. And we'll do the same with these two. So we know that there are 10 millimeters in a centimeter. So 10 times 12 is going to be 120. And we all know that 120 is greater than 102. And then we'll look down here. We know that 1 meter equals 1,000 millimeters. So out of these 1,000 millimeters or 1,200 millimeters, we know which one is larger. So since this is base 10, it's a little easier to switch between centimeters, meters, kilometer, and millimeters because we don't have to deal with the fractions. So here's just another little thing. I've already said this, 1 centimeter is 10 millimeters. So if we go to measure this little image here, this line, 1, 2, and then it's not quite to the 3, so that's going to be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. So we know that this line is 2.8 centimeters. And now if we go to millimeters, if it's 2.8 centimeters, that means that there's going to be 28 of these little lines. Therefore, it's going to be 28 millimeters. Oh, I went back. So if we're rounding, we've already said that it's 2.8 centimeters. What's the nearest centimeter? It's going to be closer to 3 because it's already over 2.5. So now that we've kind of talked about the length measurements of the metric system, let's look at the volume measurements. We're used to gallons and quarts and fluid ounces. We see it on our soda, our energy drinks, our liquids for our vehicles, all of those things. But for the metric system, we use liters and milliliters. As you can see here, we're just comparing the ones that we most commonly see. But volume isn't just a liquid. So volume is just the amount of space an object takes up. So the base unit is going to be liter. It can be represented by lowercase or uppercase L. And it's important to know that 1 liter is the same as 1 decimeter. But we don't normally use the term decimeter whenever we're talking about stuff. We will most likely use the term centimeter cubed. And this can be represented by a cm raised to the third or cc for centimeters cubed. And that's going to equal the 1 gram. But 1 gram is English or standard. So 1 milliliter, which is what we would use for liquids, is going to be exactly equal to 1 centimeter cubed or cubic centimeter. So 1 liter equals 1,000 milliliters and 1 milliliter equals 1 centimeters cubed is going to be your main thing that you need to know for metric volume units. So which is larger? Let's play this little game again. A liter or 1,500 milliliters? Well, if we go up here, you can see that 1 liter equals 1,000 milliliters. So clearly the 1,500 milliliters is going to be larger. The next one, 200 milliliters or 1.2 liters. If we look up here, we know that there's 1,000 milliliters in a liter. So if there's more than 1 liter and we only have 200 milliliters, the 1.2 liters is going to be more. This is tricky. This last one, we have 12 centimeters cubed, or 1.2 milliliters. If we look back up here, we know that 1 milliliter is exactly 1 centimeters cubed. So out of the two on bottom, hold on, that thing will go away in a second, maybe. The 12 centimeters cubed is going to be larger than 1.2. So, another way to measure volume, if we don't have the numbers, is to use something called water displacement. So we will use water, an irregular shaped object, most likely a rock, and a graduated cylinder. So whenever we read a graduated cylinder, which is pictured here, we need to be reading the bottom of the meniscus. And this is the curve of the water on top here. So nothing too crazy, but here we can say it's 1, 41, 42, 43. Here it's going to be 43 milliliters because we're reading the bottom of this curve. So, again, you can just take time and read where this line is. And here, this is kind of going to be what you would use water displacement for, the bottom half of this slide. So the amount of water with the object, which is going to be this one. So we would read the bottom of the meniscus here. This isn't a very good picture, but we've got 200. And there's 5 spaces, so each of these lines equal 20. So it'd be 20, 40, let's go with 60 right here. So 260 milliliters or centimeters cubed. We're going to go with milliliters because it's graduated cylinder. So 260. And then without it, we can say it's right at 200. So 260 minus 200 is going to give us the volume of the object or the rock. So 260 minus 200 gives you 60 milliliters. So the difference between these two is your volume of the object. So the rock is going to be 60 milliliters or 60 centimeters cubed. But if we're dealing with a regular shaped object with straight edges, we can just do a little bit of math. So to measure the volume of a regular object, you're going to do length times width times height. So that'd be 10 times 8, which is 80, and then that number times 9. So 10 times 8 times 9. I'm going to do 9 times 8 because you can do your fingers, and you can do, yep. So then you would get 72. So 72 times 10 is going to be 720. So the number would be 720, and the unit, since we're doing centimeters times centimeters times centimeters, would be centimeters cubed. So 720 centimeters cubed. You can check me on my math. I think I'm right. If not, I apologize. So whenever you're measuring volume, you're either going to be doing length times width times height, or you're going to be doing water displacement, which is the amount of water with the object minus the amount of water without the object to get the volume of the object. All right, so this is weight or mass. Mass also has different units in metric as it does to English or standard. We're used to pounds or grams. Well, not grams. We're used to pounds or ounces whenever we're talking about English or standard. But metric, they use grams, kilograms, milligrams. Again, if you've picked up on the pattern, the metric system has the same prefixes. And it also has the same, the same prefixes. It's just depending on what you're measuring, mass, volume, or length, it's going to have the different root word. So here we have 1 pound. It looks like a pound of cheese or soap. I don't really know what that is. Let's just go with cheese. A pound of cheese is 453.6 grams. Again, going between metric and English, it's not 1-to-1. Here we have an ounce of gold. That's a couple thousand milligrams. And then here, kilograms is going to be 220 pounds. So we could say that that person weighs 220 pounds here, but across the sea or the Atlantic Ocean, they use a metric, so they're going to be like, oh, they're 100 kilograms. So again, they're not 1-to-1 ratio. Here, the pound is bigger than a gram, and so on. So the same little game we played earlier. So whenever we're talking about mass, this refers to the amount of matter in an object. So the base unit of mass for metric is going to be your kilogram. If you noticed earlier, our base units didn't have a prefix, but weight's a little bit different. So the base unit is going to be kilogram. So 1 kilogram is equal to the IPK, the International Prototype Kilogram. And that's just like a platinum iridium cylinder kept in a specific thing. That's just to know what the standard is. So the major thing that you need to know for mass metric units is 1 kilogram equals 1,000 grams, and 1 gram equals 1,000 milligrams. So whenever knowing this, let's look at the bottom here. So what's bigger, 1 kilogram or 1,500 grams? Well, we know that there's 1,000 grams in a kilogram. So 1,500 or 1,500 grams is going to be larger. B, so 12 or 1,200 milligrams or in gram. We know there's 1,000 milligrams in a gram. So in this case, there's more milligrams than there are grams. So the milligrams is larger. So next, we're comparing 12 milligrams or 12 kilograms. Well, we know that there are 1,000 grams in a kilogram, and then there's 1,000 milligrams in a gram. So that's going to be 1,000 milligrams for every gram, and then 1,000 grams for every kilogram. So that's already 12,000 grams. So that's like a whole lot of milligrams. So clearly the kilograms is larger in this case. And then the last one, 4 kilograms or 4,500 grams. Again, 1,000 grams are in a kilogram. So 4 kilograms equals 4,000 grams. So 4,500 grams is larger. So measuring mass. So back in 8th grade science, you should have learned that whenever we measure mass, you will use a triple beam balance. You won't be doing much of this in my class, but you should have had exposure to this back in 8th grade. If you ever do have to use one of these, or this is similar to the weight, the scales they have at the gym, unless they have a metric one, you will move the blocks. You'll use the biggest one first, and then then you'll get smaller, and you'll just add them all together for the mass. So that's just explaining how to use a triple beam balance. So those are metric units for those types of measurements. Let's switch over to this other one. So this is just some more measurements here in this Google Slides that also contains your questions for your assignment. Okay. So kind of like I talked about earlier, the metric system is based on the base 10 numbers system. So it's very easy math compared to the fractions of the other ones. Other countries and scientists all use this for measurement. So whenever we do science in America, someone else from a different country can go in and look at it and, do the same thing, and they don't have to worry about converting everything. So these are your prefixes. So this is included in your cheat sheet, I believe. If not, I apologize for lying. But as you can see here, you've got your unit. So your base unit here, which is the 1. So that's going to be your meters, your liters, or your grams. We don't really use deca or hecto a lot. So if you go more than 1, you will go to kilo. So that's 1,000. So it takes 1,000 of whatever this is to equal one of these. Now, we do use these 3 smaller ones. So if you remember way back whenever you first started learning math, this is the 10th place, this is the 100th place, and this is the 1,000th place. So this is going to be milli for 1,000. Sorry, my speech impediment did not let me say that very well. So the 1,000th place for that one, centa will be the 100th place, and deci will be the 10th place. So this kind of tells you how you should be moving your decimal, to the left or to the right. This is just another way to say, look at the same things we just looked at. You've got your ones, and if you need to go to the left, well, this should be backwards. But this is getting smaller going this way to the right, and this is getting larger. And these are how you write them down. So meters. Meters measure length or distance. 1 millimeter is about the thickness of a dime, so that's not very big at all. 1 centimeter is probably around the size of a paperclip or your fingernail. So this is just giving you some everyday items to compare these measurements to. So millimeter is about the width of a dime or the thickness of a dime. And then a centimeter is about the width of a paperclip. And then a meter is about the width of a doorway. So that just kind of gives you some things to compare these distances to. A kilometer is about 6 city blocks or 10 football fields. So that's a pretty long way. A kilometer or kilometer, however you want to say it, is like 10 football fields. And we know that 1 mile is about 1.6 kilometers, because if we remember from the last set of slides, they're not the same distances. So next is mass. We just kind of talked about distances or lengths, and now we're going to talk about mass again. So in the metric, we use grams to measure an object's mass or weight. So a milligram weighs about as much as a grain of salt. So it's super light. You probably wouldn't feel it unless you're really thinking about it. And 1 gram weighs about as much as a small paperclip. A kilogram weighs about as much as 6 apples or 2 pounds. So that's going to be like if you buy a bag of apples from the store. Unless it's a big bag, then it might be 2 kilograms. But though, again, just gives you some references. So we've all seen the soda bottles. They're a 2-liter soda bottle. It measures liquids. A milliliter is about the amount of 1 drop. So if you have a little pipette or a little medicine dropper thing, it's just like 1 drop. A liter is half of a 2-liter, because if it's a 2-liter, there's 2 liters. A kiloliter, which we won't use a lot or ever, is like 500 2-liter bottles. So it's going to be 1,000 liters. So the rest of the slides in this document are going to be the questions you need to answer on a Google document. So you will create a Google document in the measurement question assignment on Google Classroom. You'll click on the assignment. Up in the right hand corner, you will have the create, and you want to hit Word Doc. You want to number 1 through 12, and then you will answer the things for these slots. So like on this one, which unit would you use to measure the length of this bicycle? So you got to think, what units measure length? And then you got to think about, well, how big is a bike? So if a bike, a bike that you would ride, it wouldn't make much sense to measure this in, let's say, millimeters, because that'd be a lot of millimeters. So you want to choose whatever unit best fits that. And that's what you would go here. You need to pay attention to if it's asking for mass, a length, or a distance, or if it's asking for volume. So that's how you're going to kind of go through these questions. Again, you are going to create a Word document in the measurement questions assignment and answer these questions 1 through 12. Okay, and then, let's see. After that, you're going to be doing scientific notation. Let me go down and click on that assignment real quick. So I'm going to pull up this Word document. So on this one, you whenever you click on it, you're going to want to hit open with, and then you want to hit Google Docs, and it'll take you to your own document. So on this one, after you watch the video that's attached, just don't go straight to this unless you already know how to do it. So on this one, our goal is to make it a smaller number. And scientific notation is normally like, one example would be like 1.8 times 10 to the fifth. So if we want to switch that back to a normal number, we would move the decimal to the right 5 places. So on this one, we want to convert this to scientific notation. So to do that, you're going to count how many places you need to go to the left to make this decimal number between 1 and 10. So to make this between 1 and 10, we need it to be 3.7. So to make that 3.7, we're going to go, or 3.76, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whenever we write that over here, that would be 3.76 times 10 to the 10th. And you'll see that on the video as well. So that's going from a large number to scientific notation. But what if we want to go from scientific notation to a large number? We're going to kind of do the opposite. So we know that these 3 numbers have to be included. And we know that we need to move the decimal this many places. So to go from this to a big number, we're going to move to the right because it has a positive exponent. So we're going to put 6, 4, 8, and then we'll go 1, 2. And if we take that number, 2, away from 6, we get 4. So then we need 4 zeros. So it's going to be 6, 4, 8, 0, 0, 0, 0. So that's going to be 6,480,000. Now, if you noticed, I said something about a positive exponent. If we have a negative exponent, that means that the original number is very small, not very big. So if we go up here, this is a very small number. So, however many you have to move this direction, that of course is going to be your exponent. But since you have to make a smaller number into scientific notation, your exponent is going to be negative. Again, all of that is explained in the video that is attached, which is right here. Go ahead and try that. If you need more help, please email me. I'll be available on my phone unless my internet does some weird stuff. But that's all I have for you today. Again, if we have a virtual day tomorrow, same ordeal. I'll have everything posted no later than 1. I'll probably post a little less stuff tomorrow, but we will have to talk about density tomorrow. Hopefully I get to see you in person, but if not, stay warm, stay safe, enjoy the snow. Email me if you have questions, even if you need help with your other homework, I can probably help. If not, that's fine too. So, good luck. Let me know if you have questions, and I will talk to y'all soon. Bye, guys.